Hey GPT, can you ask me some of the questions of the deep learning and Python?
Of course, I'd be happy to. Would you like a mix of both topics, or would you prefer I focus on one first? Like deep learning questions or Python questions? And do you want more conceptual questions or hands on coding problems?
Just conceptual question. You can ask me like mixed questions of the deep learning and Python. I will try to give you the answer.
That sounds great. All right, here we go. First question. In deep learning, can you explain what a convolutional layer does and why it's important in a CNN? And on the Python side, what is a lambda function and how is it typically used? Go for it.
Okay, so I have to answer what is a CNN. So it's a convolutional neural network. It is a deep learning model and it uses for the images because it is best for images. It basically moves over the image. It contains filter and their filter moves over the image to extract the edges. That's why we prefer always CNN, and it is like extracting the edge, like the shape of the uh, image, the like lines of the image, the curve. So it basically contains filter and it moves over the image to extract the edges. And talking about the lambda function, so it's anonymous or it's a function with the lambda keyword, and it's we can say no name function, and it is basically used when we have to calculate some mathematics, when we do operations like map filter, then we always go with the lambda.
That was a really solid explanation. You captured the essence of CNNs really well. Filters sliding over the image to extract patterns like edges or textures. And yes, exactly, lambda functions in Python are super handy for quick throwaway functions, especially with things like map or filter. Nice job. Want another question?
Yes.
Awesome. All right, next one. In deep learning, what is the vanishing gradient problem and why is it a challenge during training deep networks? And on the Python side, can you explain what a decorator is and give an example of when you might use one? Go for it.
Okay, so vanishing gradient problem, it's a like very big problem when we training a model, like when we are going backward from the output layer and when we are trying to calculate the derivative, then we get a like very less value. And then when we are calculating the derivative of each point and then multiplying them across the layer, because we have a lots of layers, and we basically calculating, when we are calculating the derivative, when then we are going to get a very low value. Then we are going to calculate the derivative of another point, then again we are going to get very low value. But when we are multiplying the very low value with the very low value, then we are going to get more get we are going to get more less value. So that's a vanishing gradient problem where it becomes like zero, absolute zero. So that's why our deep learning model stop learning, and that's why it fails to learn the complex pattern. It stops learning. And talking about the decorator, so it's a special function that adds some extra behavior to the original function without changing it. Maybe you are doing something before the main function and also doing after the main function, and there we have to make basically a decorator function, and inside that we have to take a FUMC function, which is our like showing the that original function. It is basically pointing to the original function, and then we have to also wrap the original function. We have to make the wrapper function here with the def keyword, and then you can do some things like print before, and then we have to call the original function, and then we can do something like print to after, and then we can return the wrapper. So this is how actually we go with the decorator and the vanishing gradient problem.
That was really well explained. You nailed the vanishing gradient. Basically, as gradients shrink layer by layer, they just get too small for the network to adjust. And your decorator explanation was spot on. It's a neat way to add behavior like logging or timing around functions without modifying them. Great job. Let me know if you'd like another concept.
Yes, of course. Another question.
Sure thing. All right, here's another one. In deep learning, what is overfitting and what are some common techniques to prevent it? And on the Python side, can you explain the difference between a list and a tuple and when you might choose one over the other? Go for it.
Okay, so let's what is the difference between list and tuple? So list is a data structure, and like basically both are the data structure, and list is a mutable, and list is contains square brackets, and whereas tuple is immutable and it contains basically C brackets and round brackets we can say, and it is faster. Basically tuple is faster than the list. And talking about the what overfitting, so overfitting means when our model start to learn the when it is well on the training set, but it is like failed on the new unseen data, so we uh, we say that it's a overfitting model. So for that we always go with a dropout, where some of the neurons randomly turn off like 30% or 40%. We use random neurons every time when we are training a model.
That was fantastic. You really got both concepts nailed down. Exactly. Lists are mutable, can be changed, and they're enclosed in square brackets, while tuples are immutable, enclosed in round brackets and a bit faster. And your overfitting explanation was spot on. The model memorizes the training data but fails to generalize. And yes, dropout is a super common technique to tackle that. Awesome work. Let me know if you have another one you'd like to discuss.
Okay, I now want to end this session because I think it's enough for my English and also for my all the explanation thing like communication skill and all.
That sounds great. I'm really glad you got some solid practice in, and you did really well. If you ever want to come back and practice more or just discuss anything else, I'm here. Take care.